In the United States, the year each coin was minted is printed on the coin. To find the age of coin, simply subtract the current year from the year printed on the coin. The ages of circulating pennies are right skewed. Most circulating pennies were minted relatively recently, and extremely old pennies are rare. Assume the ages of circulating pennies have a mean of 12.2 years and a standard deviation of 9.9 years. Based on the information given, can we determine the probability that a randomly selected penny is over 10 years old? Right? So we have to think about the conditions of whether it's normal or not. So if we look at the population, we know that it's right skewed. We don't know anything about a sample size at this point. So since it's right skewed at this point, we haven't learned any methods to determine the probability. So we cannot determine the probability because the population is not normally distributed, it's right skewed. Right? So because the population of the ages of circulating pennies is not normally distributed, we cannot determine the probability that a randomly selected penny is over 10 years old. Right? So we need it to be normal at this point. Right? So part B, we want to know what is the probability that a random sample of 40 circulating pennies has a mean less than 10 years. So again, point out the keywords here. Random sample of 40 tells us we're working with a sampling distribution, and we have a mean less than 10 years. So we're working with the sampling distribution here. Okay. So n is 40. So since n is greater than or equal to 30, the sampling distribution of x bar is approximately normal. We also want to find the mean and the standard deviation for the sampling distribution. So our mean is the same mean. That is 12.2. And our standard deviation is the population standard deviation over the square root of n. So this is 9.9 divided by the square root of 40. So let's get an approximation here, just so we have an idea. So 9.9 divided by the square root of 40. So 1.56537. So be careful as you're working through your homework with the number doesn't place it asks for you to round to. So now that we found our mean and standard deviation, we can calculate our probability. So we're looking for the probability that x bar is less than 10. So what are we going to do in StatCrunch here? We're going to use this. So our mean is going to be 12.2. And our standard deviation, we're going to type in 9.9 divided by, this is really cool, you can actually type in square root, so we're going to use SQRT parenthesis 40, and I was typing the square root of 40 for us, and that way we're not rounding our standard deviation. And then we're looking at the probability that x is less than or equal to 10. Right, so let's type those in. 12.2, and this is 9.9 divided by SQRT 40. And we'll hit compute here. Oops, and we forgot to change this to less than or equal to 10. So we get 0.0799 here is our answer. Right. So the next part we want to look at a random sample of 40 circulating pennies. So we're still talking about random samples, so sampling distribution, and then we want a mean greater than 10 years. So the same idea here. So we're looking for the probability that X bar is greater than 10. Right? So same thing here. So the mean is going to be 12.2, and our standard deviation is still going to be 9.9 divided by the square root of parentheses 40 close parentheses, and we're looking at the probability that X is greater than or equal to 10. That's what we're going to type into StatCrunch here. I just need to change one symbol. So this is 0.9201 answer here. And the last part here, we want to know the probability that a random sample of 40 has a mean greater than 15 years, and would it be unusual? So working with the sampling distribution, so our mean is 12.2. Our standard deviation is 9.9 divided by the square root of our sample size, which is 40. And we're looking at the probability that X bar is greater than 15. So we're trying to find here. So I'm just going to, I need to change this greater than or equal to 15, and then we're going to hit compute, and the answer here is 0.0368, and would that be unusual, right? So this is unusual. That's our probability, right? Is less than, the magic number here is 0.05.